into, so we'll start from here. Now f of minus 2, if I have to find f of minus 2, I can see f of minus 2 will be 2 into minus 8 plus 9 into minus 2 square plus 6 into, that is 36 plus 1 minus 12. Right? What will it be? 16 and 12 is 28, mean 9. That is a positive value. This means this is going to be your minus 2 comma 9. So a good idea is this. And I also know f double dash x is negative. This means कॉन्केव डाउन होगा. कर्व कैसा होगा? कॉन्केव डाउन होगा. कहां तक होगा? -3/2 तक होगा, क्योंकि -3/2 तक f डबल डैश x नेगेटिव है. Now from -infinity to -2 the function will be like this. Let us examine the increasing decreasing nature also. So if this is -2, this is -1. The function fx increases till -2, decreases from -2 to -1, and then increases from -1 to infinity. So -infinity to -2 I am increasing, -2 to -1 I will increase, but there is a difference. Till -3/2 it will be concave down, and after -3/2 it will be concave out. So this portion from -infinity to -3/2 it is concave down, from -3/2 to infinity it is concave up. This is the point where concavity is changing. If I draw tangent at any of the point in this portion, it will be above the curve, say like this. In this portion it will be below the curve, but this point of transition, the tangent will be crossing the curve. The tangent will be crossing the curve. So the portion where f double dash x is negative is called concave down. The portion where f double dash x is positive, it is called concave up. We use multiple things in plotting a graph, knowing the shape of the graph. It is the concavity, it is the increasing and decreasing nature, and it is the value of the curve at some few points. At -1 also I can see f of -1 will be -2 plus 9 minus 6 plus 1. That is a positive value, that is equal to 2. Right? 9 and 1 10, 10 minus 8 is 2. So this point is -1 comma 2. I hope this should make at least concavity clear to you. We'll further keep applying concavity, but next point that comes into our mind is, what is this point of transition where the concavity of a curve is changing, right? So let's discuss this. This is called a point of inflection. A point on a curve, and curves should be such that tangents at all points in the given interval can be drawn. curve should be such that a tangent should exist at all the points, right? A point on the curve where concavity changes is called point of inflection, right? Let us take an example. Let us take fx equal to x cube. To analyze this, again this is a polynomial, so it is a differentiable function. Let us differentiate it. Let us redifferentiate it. What this gives me is 6x will be negative when x is negative. This means f dash x is for all x negative and f double dash x is positive for all x positive. This means it will be concave down here and it will be concave up here. At x equal to 0 function is 0. So it will be something like this and something like this. This is the point where concavity is changing. And this is the point of inflection. This is the point of inflection. The tangent to this curve here is this x-axis. It crosses the curve. So at the point of inflection, the tangent line crosses the curve, right? So if I go into a little bit of theory, I can say f double dash x is negative, then it becomes 0, and then it becomes positive. So for finding the point of inflection, I have to see where the sign of the f double dash x is changing. In this case, this transition is going through 0. In this case, the transition is going through 0. Let us discuss one more case. Fx is equal to x की power 1 by 3. If I find f dash x, it will be minus 2 by 3. And if I redifferentiate it, it will be minus 2 by 9 x की power minus 5 by 3. Again I can see this value f double dash x will be positive when x is negative for all x that are positive, right? A very simple concept. Okay. Again we'll try and draw. The catch here is you must know that at 0 f dash x does not exist because it will tend to infinity, but a tangent line exists and that is the y-axis. So this difference you should know, that f dash x may or may not exist, but tangent line can exist, and it is only one case when the tangent gets parallel to y-axis. So if I draw this curve, it will be something like this, right? The tangent here also crosses the curve and it is the y-axis. It is the y-axis, right? In this portion, as I have seen, f double dash x is positive. You can also see it is concave up. Here f double dash x is negative. You can see concave down. This means at this point concavity is changing. But if I discuss f double dash x at 0, neither f dash x exists nor f double dash x exists. So I can say till 0 f double dash x was positive, then it became does not exist at a point, and then it becomes negative. So for finding point of inflection you can use this logic also, and you can see the transition can happen in two ways. F double dash x from positive to does not exist to 0, or as was in the previous case, f double dash x is positive or negative here. If positive, then it becomes 0 and then it becomes negative, or negative here, then 0, then positive. So concavity is changing, but the transition can be through 2 points. Either f double dash x gets 0 or f double dash x gets not defined. In both the cases, you will get a point of inflection. So this is how you will define the point of inflection. Right? Revise through this lecture and then we can continue to some problems. Thank you for watching.